Today we are converting strings into camel case, dealing with supermarket queues, sorting the odds, preserving the evens, and then we play around with logarithms and the sigma notation in order to determine the number of trailing zeros in the factorial of n. Hello world, and this is Versus Codewars. We begin today with the warm-up segment, a series of easier katas in order to prepare for the more difficult katas later on in the episode, starting with converting a number to a string. The goal of this kata is to convert a number into a string. There are several ways we can do this. Let's go ahead and hit train on this. Our function signature looks like constant number to string, and it takes a number as an argument. There are several ways we can do this, and I'm going to show them to you here. First, we can use the number objects to string method to convert that number into a string. Alright, let's go ahead and feed that into Codewars and see what that looks like. I'm going to hit test instead of submit just to run the initial test here because I want to show you some other ways this can be accomplished. Alright, here is another way to do this. If you concatenate a blank string onto a number, JavaScript will implicitly convert that number into a string, and a string is what will be returned. Let's go ahead and punch this into Codewars next. And as you can see, the tests pass again. A third way we can go ahead and go about this is using template literals. If you use the backtick, which is to the left of the 1 key, and you can, if you use a backtick, which is to the left of the 1 key, you can go ahead and do this. $, curly braces, and inside those curly braces you can do number, and it will put the value of that number into the template string and implicitly convert that into a string as a result. Let's go ahead and punch this into Codewars next. And the test passed right here. One other way we can convert this into a string is by using the string objects constructor explicitly. By doing the string and in the parentheses pass a number. Let's feed this into Codewars. And let's run those tests, and as you can see, those tests pass. Alright, I'm going to go ahead and put my initial solution back here. Number.toString. I'm going to feed this into Codewars here and submit it. We are good on that one. For our next warm-up, we are removing the spaces from a string and returning the resultant string. Alright, our function signature looks like no space, and it takes our string as a parameter. What I think we'll go ahead and try doing here is we can simply do this. String.replace. We'll try using a regular expression here. Capturing sequences of at least one space, and then we'll replace any matches of that regular expression to the string with a blank space. Let's go ahead and punch this into Codewars and see what that looks like. As you can see, the test passed. There is yet another way we can do this here. The string object also has the replaceAll method, which replaces all instances of a certain character with another character. So let's try using the replaceAll method with the blank string, with the space, and replace those with a blank string. It might not work at all times, but yeah, just know in later versions of Node this method will exist. But in any event, let's go ahead and bring back our other solution here and punch this into Codewars here and submit it, and we are good on that. For our next warm-up, we are checking to see who's a friend and who's a foe. If someone's name has exactly 4 letters in it, we can be sure they are a friend. Otherwise, we can't really be sure. Let's go ahead and hit train on that. Const friend. It takes a array of strings representing each of our friends. And what we can go ahead and do here is run the filter method. Passing in each of our friends' names here. And we filter out any names whose length is not 4 characters. So name.length is exactly equal to 4. Alright, let's go ahead and punch this into Codewars here. And submit that, and we are good on that. For our 4th warm-up kata of the morning, we are dealing with printer errors. In a factory, a printer prints labels for boxes. For one kind of boxes, the printer has to use color, which for the sake of simplicity, are named with the letters A through M. The goal of this kata is to find out which colors in our control string do not match up, do not range from A to M. Each color outside of this range represents a printer error. The goal of this kata is to write the function which will give a string which will return the error rate of the printer as a string representing the rational whose numerator is the number of errors and denominator the length of the control string. Let's go ahead and give this one a try. Alright, our function signature is const printer error. It takes a control string. And what I think we'll go ahead and do here is we're going to be returning a template literal here. So we're going to be returning, putting something in these curly braces here. And on the other end, we'll be doing control string.length. Alright, let's figure out what goes in here. Alright, what we're going to go ahead and try doing here is const error count equals, what I think we'll go ahead and try doing is splitting the string into its individual characters. Then we're going to go ahead and filter out any character which matches our A to M. All right, I have a new idea actually. Const error count equals let's set up a regular expression here actually that captures any instance of the letters A through M. And then what we'll go ahead and do is const error count equals control string dot replace, pass in our color regex, and then a blank string. And then from there we can go ahead and get the length. Let's pass in our error count over here. Let's run some test cases on our local machine here. Console.log. Oops. It's printer error. Oops. I gotta put this. This is supposed to be a string here. Let's feed this in a node and see what that looks like. Node warm up printer errors. And we do have eight printer errors out of 22 characters in our control string. Let's go ahead and feed this into Codewars and see what that looks like. And let's attempt here. And we have a problem. Because there's apparently no spaces in our return string here. Let's go ahead and try that again. Get rid of this console.log here. Let's try that again. And we are good on that. Finally, we are categorizing new members. The Western Suburbs Croquet Club has 2 categories of membership, senior and open. They would like our help with an application form that will tell prospective members which category they will be placed. To be a senior, a member must be at least 55 years of age and have a handicap greater than 7. In this croquet club, handicaps range from -2 to +26. The better the player, the lower the handicap. The goal of this kata is, given an array of pairs of numbers, the first integer of which is the age and the second being the handicap, the goal of this kata is to map out which category each individual represented by these pairs will be placed in, either open or senior. Let's go ahead and get started with this one. Let's hit train. Alright, function signature is const open or senior. I'm passing our data here. And what we can go ahead and do is, now since we know this array will be of pairs of integers, what we can do is, I think we'll do data.map, pass in datum to our predicate function here. And what I think we'll do is, if the first element of our datum, which is the individual's age, is greater than or equal to 55, and datum at index 1, which is their handicap, is greater than 7, then we'll go ahead and place them in the senior category. Otherwise, we'll place them in the open category. Alright, let's go ahead and test this out on a data set here. Alright, console.log open or senior. And pass in this array here. Array of pairs here. Alright, let's run this through Node and see what that looks like. Open, open, senior, open, open, senior. Alright, let's go ahead and punch that into Codewars and see what that looks like here. And we are good on that. That concludes today's warm-up segment. I will see you in the next kata. Before we go on to the next kata here, I want to explain what was going on in the second warm-up kata. The test cases in that kata were being run on Node.js version 12. The String.replaceAll method is new to Node.js version 15. As a result, in Node 12, the method was unsupported and thus undefined, resulting in the failed tests. Given a string with dash, underscore, or space-delimited words, this function converts that string into either camel case if the first letter of the first word of the string is lowercase, or upper camel case or Pascal case if that first letter is uppercase. Let's go ahead and give this a try here. I think we'll use a regular expression again for this one. Const delimiter regex. This one will capture either dash, underscore, or a space. and then a letter. All right, what we'll go ahead and do from here is what I think we'll go ahead and do is return str.replace. Oh, I have another idea. What about placing these in capture groups here? Nah. Anyway, we'll do str.replace delimiter regex, and then in our replacer function here, we'll take match as a parameter. All right, what I'm gonna go ahead and try doing here is let's take this string here, console.log to camel case. All right, now in our replacer function here, let's just go ahead and console.log our match and see what each one looks like. All right, let's speed this into Node and see what that looks like. Our dash S, we have our dash W. Let's try a space here next. Space S, space W. All right, what we'll go ahead and do is, now because this regular expression is probably guaranteed to capture 2 characters per match, what I think we'll go ahead and do is return match at index 1 to uppercase. And that should get us our string converted into camel case. Let's try another edge case here. Capital T, the stealth warrior. And that should convert our string into Pascal case, which is what we want here. Let's try some other edge cases here. Blank string returns a blank string. All right, let's go ahead and try feeding in this into Codewars and see what that looks like. And we are good. Not really much to say about this one, but another solution that would have worked was to take the letter character class in the delimiter regular expression and encapsulate it in parentheses to indicate a capture group. In the replace method's replacer function, I would have put in a second parameter in that function, and that parameter would be whatever was matched specifically by that capture group in the regular expression, which would have been the letter after the dash, underscore, or space. I could have taken that letter and returned it uppercase, instead of accessing the match string like an array and accessing the second element of that string, which would have been the letter. Given an array of integers, each one representing a customer at a supermarket and their values representing how long they take to check out, and an integer representing the number of checkout tills available, the goal of this kata is to calculate the total time needed for all customers to check out. Let's go ahead and get started with this one here. First, let's handle some edge cases here. If there are no customers, customers.length is 0. We just go ahead and return 0. All right. If there is only one till available here, we can just go ahead and do customers.reduce. We can just go ahead and add up all of the customer checkout times here and just return that. And if there are more tills available than customers, if there are as many or more tills available as customers, we can just go ahead and do return mat.max customers. Alright, so here are the edge cases right here. If there are no customers here, the length of the customers array is 0. We just go ahead and return 0 because there's nothing for the checkouts to do. If there is only one checkout till available, we just go ahead and calculate the sum of the integers of the customers array here and just return that because that's how much time it'll take for all customers to check out. Now, if there are as many checkout tills or more checkout tills than customers checking out, alright, we just go ahead and return the maximum value of the integers in the customers array. Alright, with these edge cases done and out of the way, let's go ahead and get to the meat and bones of this kata here. The meat and potatoes, that is. What I think we'll do is we'll break these into individual queues here. Till queues. New array. And we'll set the length of this new array to our customers, no, our tills. Then what I think we'll go ahead and try doing here is for const customer time of customers, we'll go ahead and sort our till queues array in ascending order. Queues.sort. And then what I think we'll go ahead and do from here, and with this sorted, the first element of that sorted till queues array should be the minimum value of the elements of that array. So what we can do is till queues at element 0 plus equals customer time. And I think we need to fill this with zeros. And then what I think we can do from here is return math.max, spread out our till queues array here. Alright, let's go ahead and grab some tests here and try this implementation out. Console.log queue time. Let's try the empty array and one till. Let's feed this into Node and see what that looks like here. Node supermarket queue. And we get 0. Let's try the array 1, 2, 3, 4 with one till available. Till is not defined. It should be tills. And we get 10, which is what we want. Let's try passing in 2 here. Into constant variable. Okay, this needs to be a let. And we get 6 here. 1, 2, 3. Yeah, that sounds sound to me here. Let's try another test here. 2, 2, 3, 3, 4, 4. And we get 9. About 100 tills. 1, 2, 3, 4, 5. Let's try that. And we get 5. I think this is sound. Let's punch this into Codewars and see what that looks like here. And we are good. Here in our Kata solution, with each iteration of the customer time for loop, we were sorting our tills queue array in ascending order, ensuring that the minimum value of that array was always the first element therein. However, what if we had instances where we had a ton of customers and a lot of checkout tills to work with? This operation would be woefully inefficient and would take forever. Which brings us to our better code solution of the day. Pay mind to the code snippet you see below me here. Why sort every iteration when you can just calculate the minimum value of the till queues array and then use the array object's index of method to get the index of that minimum value and then modify the element of that tills queue array as proper? This would be a lot more efficient and would save a lot of time, which is something you always want to do when coding algorithms. Given an array of integers, the goal of this kata is to sort the odd integers in ascending order while preserving the order of the even numbers, their positions in the array. Let's go ahead and give this a try here. First, what I think we're going to do is filter the odd numbers into its own array and then sort that. Const odd numbers equals array.filter number. Yeah, we're going to go ahead and filter the even numbers out of this array and store the odd numbers in here. And then what we'll go ahead and do with that resulting array is sort that in ascending order. All right, let's go ahead and console.log that and see what that looks like here. Let's go ahead and do console.log sort array. We'll do 987654321 All right, let's feed that in a node and see what that looks like here. Node sort the odd. And we have our 1, 3, 5, 7, and 9. The odd numbers of the array filtered out and sorted in ascending order. Let's go ahead and... All right, with that being said, what we will go ahead and do is return array.map. We'll pass in our number. And if the number is even, we just return the number. Otherwise, we'll return odd numbers dot shift. Yeah, this will pop one of the odd numbers out of the beginning of the odd numbers array here and return it. All right, let's go ahead and feed that in the node and see what that looks like. We have 1, 8, 3, 6, 5, 4, 7, 2, 9, 0. Which is our array with the odd numbers sorted in ascending order and the order of the even numbers preserved. Let's go ahead and punch this into Codewars and see what this looks like here. Let's run some tests here. And we are good. Not really much to say about this one either, but I think this would be a good time to bring up the fact that in addition to adding elements to and removing elements from the end of a JavaScript array, there also exists methods in the array object for adding elements to and removing elements from the beginning of the array. You saw one of these elements in the Kata solution here, which is the shift method, which removes an element from the beginning of the array and returns the value of that element. The unshift method does the opposite, adding a new element to the beginning of the array. Given a positive integer, the goal of this kata is to calculate the number of trailing zeros in the factorial of that integer. Before we get started here, I want to point you to this equation right here that is used for calculating the number of zeros in the factorial of n. What you see here is known as the sigma notation. It basically means to sum up a sequence of numbers. For instance, you have two numbers on the top of this sigma here, and then a number to the right. The bottom number is the start point. And let's say you had x equals 1 on the bottom here. The number on the top here is the end point. For instance, let's set it to 4. And then you have to the right of the sigma here, the sequence here. Let's say we had x right here. So if x started at 1 and ended at 4, we would add up 1 plus 2 plus 3 plus 4, because this means sum up the sequence. In this particular case here, we have our start point k at 1, and our end point k sub max right here, where k sub max is approximately equal to the base 5 logarithm of n, which is the same n that we pass into this kata solution right here. And the sequence consists of n over 5 to the power of k, and we want to add up all of the results of that sequence right here, and that's how we get the number of trailing zeros in our factorial here. Alright, with that being said, let's go ahead and give this kata a try, shall we? First, what I think we'll go ahead and do is... first, we need to go ahead and get the base 5 logarithm of n here. And we can do that by doing this. I have the math.log function documentation open here in MDN. And it says right here, if you need a logarithm to other bases like 5, use math.log passing in x divided by math.log other base. So we can go ahead and do that like this. Think const end step equals math.log n divided by math.log 5. This should get us the base 5 logarithm of n right here. And what we'll go ahead and do is for let k equals 1, k is, I think, less than end step plus k. And I think in here, what we need to do is we'll need to keep track of the result here. Result plus equals, we need to take n divided by 5 raised to the power of k. So we'll do n divided by math.pow 5 to the power of k. Alright, let's go ahead and console.log that and see what that looks like. Alright, I'm going to go back to the kata here. Let's try console.log zeros passing in 6. Let's feed that into Codewars and see what that looks like here. Node factorial trailing zeros. 1.2. What about 12? Whoops. 2.4. I might need to floor that here. Oops. Yeah, we have 2. Yeah, this result should be the number of trailing zeros here. Let's try 30. And we get 7. And that's not right here. And okay, what we might need to do, we might need to round this up because floating point rounding issues might come in play here. We could try rounding this here. And maybe give it a try now, and we still get 0. Maybe it could be our end step. Let's go ahead and console.log that and see what that looks like. Maybe we might just need to do this then. Alright, let's try out our tests again here. 6. Yep, and sure enough, we've got some rounding issues going on here. Let's try that, taking care of that with math.round. Or floor, actually. We might not want to do that, actually. Lower that to 1. Let's try 30. I should expect to see 7, and we do. What about 0? And we get 0. Let's try 500. 124 leading zeros. Okay. Let's take this from the top here. 0 here. Uh, 5. Alright, let's get rid of this end console.log end step here. 10 should get us 2 leading zeros. 15 should get us 3 leading zeros. 20 should get us 4 leading zeros. 25 should get us 6 leading zeros. 30 should get us 7 leading zeros. 35 should get us 8 leading zeros. 40 should get us 9 leading zeros. 45 should get us 10 leading zeros. 50 should get us 12 leading zeros. I think this is dandy here. So what's going on here is, all right, we're keeping track of our result right here. We're calculating the end step right here, which is this top value in our sigma notation here. And we're setting that to the base 5 logarithm of n here. In other words, in the JavaScript implementation of this, we take the regular base logarithm of n and we divide it by the regular logarithm of 5 to get the base 5 logarithm. We then, in a for loop, iterate from 1 to this end step inclusive, and we add the floor of n divided by 5 to the power of k to this result here. At the end of this, we go ahead and return the result. And that's how we calculate the number of trailing zeros in the factorial of n. Let's go ahead and see what this looks like in Codewars. Uh-oh, we got a problem here. Reference arrow zeros is not defined because we misspelled zeros here. We gotta drop the E in zeros. Alright, the test passed. Let's try attempting this, and we are good. Alright, there is a lot of mathematics going on in this Kata solution, so let's break it down piece by piece. First, the call is the math.log. In JavaScript, math.log calculates the base 2 logarithm of a number that is passed in. There is a way to calculate other base logarithms using this method too. For example, if you wanted to calculate the base 5 logarithm of a number, you first pass the number into math.log, take the return, and divide it by the return of math.log passing in 5 to get the base 5 logarithm of that number. The other bit of mathematics you saw in this Kata is a JavaScript implementation of what is known as the sigma notation. Alright, pay mind to this card you see right here. There are three things on either side of the Greek letter sigma here. On the bottom here is the start point of a sequence, say x equals 1. On the top of the symbol here is the end point, 5. And to the right of this symbol here is how each number of the sequence should be calculated here. For example, 2x plus 3. So you start with 1. 2 times 1 is 2. 2 plus 3 is 5. X steps up to 2. 2 times 2 is 4. 4 plus 3 is 7. X steps up to 3. 2 times 3 is 6. 6 plus 3 is 9, and so on and so forth. You take the resulting numbers of that sequence and add them together to get the solution of this sigma notation right here. What you saw in this Kata solution is an implementation of the sigma notation in which you have the start point k, which is equal to 1, and the end point k sub max, which is equal to the base 5 logarithm of n, which is what we pass into this Kata function here. And then each number of that sequence is reached by calculating n divided by 5 to the power of k, and then we add each number of that resulting sequence together to get the number of trailing zeros in the factorial of n. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.